him an extremist, but an academic extremist, I stress. He has 35 years experience and broad interests extending across climate modelling, climate change and climate extremes. And he has been a lead author on the Intergovernmental Panel on Climate Change, winning the Nobel Peace Prize in 2007. Congratulations, that's very impressive. He was a review editor of the 2013 report. He has had multiple senior advisory roles in climate science for the federal government, the New South Wales state government, as well as the senior national roles in e-research infrastructure strategy. He won the Priestley Medal in 2004, the Amos Medal in 2009, the New South Wales Climate Scientist of the Year in 2010, the Royal Society of Victoria Medal in 2020, and was elected Fellow of the Australian Academy of Science in 2021, i.e. he's a very smart person. He is also a Fellow of the American Meteorological Society and the Australian Meteorological and Oceanographic Society. Professor Pitman, before we throw to you on climate change, how likely is it that the world could be destroyed by an asteroid?
Awesome question. Not very.
Not very. On that note then, ladies and gentlemen, Professor Pitman, please tell us everything we don't know about climate change.
I will do my best. Can you see my screen?
We can.
Awesome.
Oh, okay. Sorry, before Professor Pitman begins, if you have any, I've had some submitted questions already. If you have any questions as we go through, please feel free to put it in the chat box and I will try to bundle them and get through them as time permits. Sorry, Professor Pitman, over to you.
Not a problem. I will try and keep this fairly brief. Someone's claiming presenter rights. I have to. Someone's interfering with my screen.
It's not me. We can see your slide.
That's interesting. I can't.
Okay. I'll just put myself on mute. See if you.
Others are happy with the prospect. I'm happy just to go straight to questions.
All right. Okay. Let me do that then. All right.
Because you had lots of questions.
Do you want to just give us a brief outline of your presentation? It's just verbal.
Sure. So I was mainly going to talk about what was in the recently released summary for policymakers by the Intergovernmental Panel on Climate Change. Many of you will have seen some of the press coverage around that. It basically restates what climate science is saying for quite a few decades. That increasing carbon dioxide in the atmosphere is causing global warming. As a consequence of that, the average temperature of the planet is warming, and we are now seeing the emergence of extreme events that haven't been seen before, both in terms of temperature, intensification of rainfall, sea level rise, a trend towards other more in terms of moving forward. Somebody keeps muting my microphone. Okay. So moving forward, we expect those extreme events to continue to deteriorate roughly at the rate at which we emit greenhouse gases into the atmosphere. The solution to this was known in the 1960s, that we have to deeply cut carbon dioxide emissions into the atmosphere. I can talk about how fast we need to do that and what the consequences of that would be in terms of answering any questions anybody has. But broadly, sorry, James.
So I was going to say, if I can go to the question, you said then that we should see extreme events decline. Is that what you said, or
increase?
Increase.
Yes.
Increase. Okay. And what is the nature of that increase? Larger, more hurricanes, or the same number of hurricanes, just of greater strength, or both?
So one of the challenges with climate change is it matters a great deal where you are. So the frequency of tropical cyclones hitting north of Australia is likely to decline, but the intensity is likely to increase. And the reason for that is that the cyclones tend to be pushed out into the Pacific. So in some of the Pacific islands, we would expect an increase in the number of cyclones and an increase in their intensity. So it just depends where you are on the planet, whether individual extreme events are a major problem to you or they're quite manageable.
Okay. One of the arguments that's going on in Australia at the moment is obviously with us coming up to COP26 is net zero by 2050 and should we update our 2030 targets? One of the arguments around the 2030 targets that Bill Gates puts forward, for example, is should you put more resources into abatement this decade or more resources into technology development that will help you get to net zero sooner than later or sooner than 2050? I suppose the answer is actually a bit of both. And really, what stress do you put on that? What you mentioned earlier, like how much should we cut carbon emissions by and by when? Would you care to weigh in on this debate?
Well, I can tell you what the Intergovernmental Panel on Climate Change says, and it depends how lucky you feel and how much you're willing to allow the Earth to warm. So if you are happy with the Earth warming to 2 degrees and you're willing to take a 50-50 chance on that being successful, we've got about 1,300 billion tons of carbon left in the global carbon budget, which at current emission rates mean net zero emissions in 32 years. That's for 2 degrees with a toss of a coin chance. If you want to limit global warming to 1.5 degrees, but with a high chance of succeeding, you've got to get to net zero emissions in 6 years. So there's no answer to these questions. It all depends on how much you're willing to allow the planet to warm and how certain you want to be in avoiding that amount of warming. So the Paris Agreement says 2 degrees is a ceiling. You cannot warm by more than 2 degrees. If you want to avoid 2 degrees with high levels of certainty, we will have expended the entire global carbon budget in about 20 years. So that says 2040, net zero by 2040. The language around net zero by 2050 says I'm willing to gamble at a 50-50 chance of failing.
Okay. All right. Thank you for that uplifting note. Okay. I better not take up all your time because a lot of people have asked questions. So Ian Milner asks, can we sustain the extraction and use of fossil fuels at the current rate and still meet the target of 1 to 1.5 degree warming? I think you might have answered that, but yeah, please.
Easy question. No, you can't. It's no longer possible to limit warming to 1 degree. It's almost virtually impossible to limit warming to 1.5 degrees with any level of confidence. As I said, if you want to limit warming to 1.5 degrees with an 83% certainty, you've got to get to net zero in 6 years. And I wish you luck in achieving that.
Fair enough. Gopala Mora, and I apologise if I've mispronounced your name, Gopala, asks, which top 5 climate reduction technologies do you think should be used globally to remove carbon from the atmosphere so that we can reduce global warming by 75% by 2030? I ask this question because I know that moving away from traditional methods of power, such as coal and gas, to renewables alone will not be enough to meet this aggressive target. And while other countries are well on their way to this, Australia is quite far behind. Europe, for example, we have been told we have 8 years to get our global house in order. So I'm keen to ensure we are focusing resources in the right areas to help achieve this goal.
Thank you. So I'm not aware of any technology that will scale up to significantly cut emissions in terms of things like removal of carbon from the atmosphere. There are many technologies that do a little bit, but this notion that you hear from governments around the world that technology will save us is a perfectly reasonable gamble, but it's a gamble. There are no technologies that allow us to extract carbon dioxide from the atmosphere at a sufficient scale. We're currently emitting 40 billion tons of CO2 a year. If you just think about 40 billion tons, sure, there are ways to remove 1 million tons a year, but 1 million tons is a tiny amount relative to emissions. So the really important story here is some of those technologies could be valuable for the last little bit to get to net zero. We have to do the heavy lifting using renewables and all of the technologies you hear about, and use ways to extract CO2 from the atmosphere for that last little bit that gets you to net zero. It's not a solution to the problem, but it's a small solution at the last to get you to the last bit of the problem.
Okay. All right. So the next question is from Corinne Miles. Sorry. What are the bushfire impacts forecast for the coming summer season?
So that's a question about weather, not climate. And the best I can offer there is I followed the advice of the bushfire services in preparing my home for the forthcoming fire season, because I've no more idea than anybody else how bad the fire season is going to be.
Stephanie Dunn asks, how can we and the planet survive if use of coal and gas isn't stopped right now?
Right. So there are people out there that have used language like we've got 10 years to save the planet and so forth. This isn't about the survival of the species. The cockroaches are not going to take over the planet. This is about minimizing the risk and making a planet that's habitable and pleasant to live on for most of the world. That means getting to net zero as soon as possible. If you can get to net zero globally by 2040, that's an adequate outcome. It's not a great outcome, but it's an adequate outcome. And the short story is that means the coal and gas stays in the ground. And that's awkward politically, but the truth is the coal and the gas stays in the ground.
Steve Erickson asks, which I think is not an unfair corollary, in that case, should Australia embrace nuclear energy as a baseload power source?
I turned up at a Greenpeace conference in 2000 and said we should embrace nuclear. It didn't go down very well. That was quite a long time ago. That was 20 years ago. It takes approximately 30 years from go to woe on a nuclear power station. You can't go and buy one at Bunnings. It takes a long time to get the small number of companies that you would trust to build you a nuclear power station to build it for you. So it's roughly a 30-year investment before it starts providing baseload power. 30 years is too late. So nuclear was a solution. Had Australia embraced nuclear back in 2000, but it's probably too late now, and it's not affordable. Renewables are much cheaper.
Barry Lambert asks, why do countries that matter have different rules? For example, China, how come New Zealand excludes output from cattle, but Australia doesn't?
That's not really a science question, it's more political, but the answer is because country X wants to measure its emissions and its success in reducing emissions in a way that suits itself and doesn't want an accountancy method imposed on it. For example, China would like emissions charged at source. In other words, where the coal is mined. So China would like all of the carbon to be paid at the time it's mined. Surprisingly, Australia would like it to be counted when it's burned. There's no scientific rationale for one reason or another. It's just countries being countries and looking at their geopolitical advantages. There is no, the fundamental point is the atmosphere doesn't give us stuff where the CO2 and the other greenhouse gases come from. It cares that those greenhouse gases are in the atmosphere. So from a science perspective, you want a means to measure that's as accurate as possible.
Marie Nutt asks, I note that other equally eminent scientists are calling for much more ambitious net zero targets, like 75% reduction by 2030 and net zero by 2035. In your opinion, is there an alarm over the findings of the recent IPCC being appropriately matched with action by the federal government? If so, how? If not, what should their key priorities and targets actually be?
So it depends how lucky you feel, as I said earlier, and how much you're willing to allow the climate to warm. That 75% reduction by 2030 is not inconsistent with the sorts of numbers I gave you earlier. So it is the right sort of number. 75% reduction by 2030 and net zero by 2040 are the sorts of numbers I think we should be striving for.
Okay. Well, the second part to that question from Marie was, so what do you think are the key action, or yes, what do you think the key actions or what are the appropriately matched with actions by the federal government? If so, how? If not, what should their key priorities and targets be? I think you've answered that last bit. But I mean, if we are to meet 75 by 2030, net zero by 2040, what actions do you think Australia should take and the federal government? And if so, how would you do that?
So those aren't science questions. Those are questions of policy. As a scientist, I can say how much you need to reduce emissions. Technologists tell us you can do that with renewables. You can reduce the emissions as the scientists tell us we need to. And then it comes down to political energy and willingness to drive that sort of change in the system. So I was part of a briefing to the Howard Cabinet in 2007, where we said, you've got to deeply cut emissions, you've got to leave the coal in the ground, and you need to diversify the economic base of the country so that when you're not allowed to export coal anymore, you can shrug your shoulders and say, I don't care. Had those decisions been acted upon in 2007, Australia would now have a profoundly different economy and have an economy built around the sorts of technologies that Matt Keane announced for the New South Wales government and other South Australia and Victorian governments have previously announced, which is a whole different nature of the economic base in the country. And we didn't do it, and subsequent Labor governments didn't do it. And so we get to 2021 with a much bigger problem than we would have had we acted when we first understood the problem.
Dr. Kelvin Wellington asks, does Professor Pitman foresee any negative effects from the strong move to electrify the planet?
Not that I can think of.
Okay. John Smith asks, why not nuclear? Back to our previous thing, and I think you might have answered this. With the current technologies available, why are our current political parties so afraid? And Professor Pitman, I do have to say, one of the changes has been, although I suppose the counter argument I'll give as well, is that with modular reactors, you can actually get them up and running within 2 to 3 years. But of course, that technology may not be commonly available for another 5 to 10. So
that's right.
Yeah.
There is serious options for modular reactions on a small scale, providing power to communities, remote communities, for example. Equally, you can do that with solar and wind and batteries. So my guess is the nuclear industry has missed its chance in Australia, that what you need in terms of base load can be provided in other ways. Battery technology is going to provide it much quicker than nuclear would be able to, but there may well be exceptions to that in some places.
Okay, we might come back to that because that goes against everything I've read. So I'm interested to know what you know that I don't, which I suspect is a lot. Hillary Green asks, the Morrison government has approved a third new coal mine within a month. Susan Lee's argument is that if coal is not dug up here, it will be somewhere else. Do you believe this government, being the federal government, has any intention of being a global citizen in the struggle against climate change, or do we not wish to hold a hose?
So not a science question, but my personal view is that it's extraordinarily hard for the Australian government to act now because it's been left so very, very late, but they have no choice to act. Whether this government or the following one are going to be under such pressure internationally in terms of everything from trade sanctions through to loss of markets for export of coal, they're going to have to act. But the short story to Hillary, the short answer to Hillary is that approving new coal mines is, well, like inconsistent with the science.
Guy Glennie asks, we hear a lot around the melting of the polar ice caps and tundra, the bleaching of the reef and the impacts of drought on our farming districts. Do you feel we are close to any irreversible tipping points caused by climate change?
Don't know, and nor does anyone else. The whole critical thing about tipping points, the nature of tipping points, is the point at which they tip is broadly unpredictable. So you can't know how close you are to a tipping point. What we do know for sure is that as you warm the planet past a further 1.5 degrees or a further 2 degrees, the risk of tipping points becomes much more real. And we really, really don't want to go there.
Okay. Greg Richardson asks, and I think you've answered the first part of this question, which is the Climate Council says Australia must commit to 75% emission reductions by 2030. Do you agree? And if so, how can Australia reach this goal?
And it all comes back to what the Climate Council say is you've got to reduce emissions by 75% for a given temperature target. So a big problem for everybody listening to this is there is no amount of global warming that is safe. 1.5 degrees is safer than 2 degrees, and 2 degrees is safer than 3 degrees. But we're already seeing the emergence of extreme events with 1.1 degree of warming. So it's not that you have to do a specific thing to limit warming by a specific amount and you'll be safe. The problem is we have already warmed the planet by 1.1 degrees. We're already seeing the emergence of extreme events. And as a consequence of that, we need to limit warming to the smallest amount possible. What the Climate Council put out here is basically well-informed scientifically if you are willing to accept a certain amount of warming.
Okay. Professor Pitman, batteries. Everything I've read on batteries says even with the latest advances by Tesla, they're not a sustainable storage device compared to a whole bunch of other technologies that we have now. That's not to say in the next few years there won't be some step up in their capacity and capability, but that's where it sits. And frankly, from Australia's point of view, we want batteries to be the answer because so much of the raw material is actually here in Australia. So what do you know that I don't? And the answer is a lot, but I'm just wondering specifically on batteries.
It all depends on what problem you're trying to solve. Batteries take out the variability of the provision of the energy from solar and wind and other sources. And something like, when I say batteries, I'm not necessarily saying lithium. Snowy Hydro 2 is a battery.
Ah, okay, right.
So I'm not being specific. I'm not being technology specific. What you've got to do is find a way to store energy from when you produce it to when you need it, and that's a battery. But that
it could in fact be clean. It could in fact be clean hydrogen as well.
Yeah.
Okay.
Right.
Right.
So I don't think of a battery as that Duracell thingy you buy from Bunnings.
Yeah, no. When you say batteries, I've got to say, I mean, some people have told me I've got this number wrong, but my understanding was the South Australian government paid about $300 million for the Tesla battery, and it doesn't actually provide energy to anyone, but it does provide stability for the grid, which allows, and then they have a gas peaker, but it means that they have a very green power grid using mostly wind, that the battery then maintains the voltage in the system, and if it stops blowing wind, then they move across to their gas peaker.
Yeah, and they build interstate connectors that have provided a much more integrated power network.
Power grid, yeah, and diversified as well. All right, we're on to the chat function here, and there are a lot of people who were very concerned when you left us and didn't look like you were coming back. However, Alistair Thompson says, how much of climate change is cyclical and how much is related to recent man-made impacts such as carbon emissions?
So the warming over the last century is not cyclical. We do understand the long-term cycles in the climate driven by things like orbital forcing, the way that the Earth's angles vary relative to the sun over very long time periods, the Milankovitch cycles, if anybody wants to play on Google. We know about those cycles. We know that the planet shouldn't be really warming at the moment. It probably should be slightly cooling. And so it's utterly not the explanation for the warming over the last century, and in particular the warming over the last 40 years. That's due to the range of greenhouse gases in the atmosphere and a small amount from land clearance.
Carolyn Cady says, Andy seems to have frozen dash in complete contrast to the Earth's warming. So I just thought I'd let you know that. Then we have yes, this is right. Michael Mathert asks, CO2 is 400 parts per million in the atmosphere, and man has contributed 100 parts of that, and Australia's contributed 1 part. These figures are normally presented to us with a confusing percentages and misleading graphs. However, 100 parts per million is equal to 10 centimetres in a kilometre. How can that much CO2 cause the climate to change? Where do the billions of taxpayers' dollars spent on renewables go? I have not seen the climate change in my life. Heat waves, floods, droughts have always been around, and the temperature is not changing, etc., etc.
Excellent. Where shall I start? The concentration of something isn't proportional to its impact. So if I inject somebody with a few molecules of an appropriate substance, your body will react to that in an incredibly nonlinear way, and you keel over and die. So the amount of something isn't proportional to the importance of something. When we look at greenhouse gases in the atmosphere, we can measure from satellites the reduction in the amount of energy escaping our planet. And we can measure the amount of energy accumulating in our land, in our atmosphere, and in our oceans. And it's connected clearly and unambiguously to the greenhouse gases, including the spectral characteristics of the energy escaping the planet to space, has exactly the signatures you would expect and the change in the signatures you would expect for each of the individual greenhouse gas changes in the atmosphere. So those questions are often asked to us, and it's fine, we don't mind, but I'm sorry, you need to get with the program. The answer to where all the money goes, God knows, I don't know, it doesn't go into research, hint, hint. It isn't. Not that much money is going into these places, these areas. Probably the entire investment in climate science internationally is the cost of one fighter jet. it's not very much money goes into these problems.
Sorry, that's the amount of research. Sorry, climate research is about globally is about 450 million US. Is that?
No, in Australia.
Oh, in Australia, right. Sorry.
The Bureau, the Antarctic divisions, CSRO, the universities, various other programs. It's not a great deal of money. I continually whinge about how astronomers get new and big telescopes, which cost a lot more than the climate science system. But there we go.
How many climate scientists is a telescope or something?
Oh, we won a Nobel Prize yesterday, so we should.
Indeed.
But no, I mean the question is one that's regularly asked, and you know, we should respect people wanting to ask those questions, but those questions have been thoroughly and unambiguously answered so very many times. There's a very nice report by the Australian Academy of Science which goes through all of those things step by step, which you can find on the internet. So you just need to go read some of those things.
So David Berry has asked, and David and I often, David gives me full and frank views on my performance as an MP, let me put it that way. David has said, a climate change bill was recently presented to the federal parliament looking to tackle the climate crisis that included legislating for net zero by 2050. David, it didn't do that, but anyway, despite overwhelming public support, I understand the bill did not get off the ground, defeated on party lines. How important is a bipartisan approach to tackling the climate change, also in terms of countries acting in concert with other countries to solve the problem, thinking COP26? I want to stress that they are the views of David and not of Jason's, but please.
I don't know. I'm not across the climate change bill. I'm afraid.
Was there one? That was hushed up.
I will.
Sorry,
I couldn't hear that. I will say that net zero by 2050, as I've said earlier, is actually no longer best practice internationally. I think COP is likely to come out with net zero by 2040. And then you get a whole can of worms on how achievable that is and how we would go about achieving it. I do think the bipartisan approach is a really important one. The laws of physics do not give us stuff if you vote left or right. It always amazes me that I often get people from a particular extreme end of politics are saying things about climate change. Climate change is physics, and physics doesn't care what political party you belong to. And so I would like the science to inform the policy on all sides.
Okay, and the guest is asking, in effect, how do we measure rising sea levels?
There's multiple ways. The first way is you actually have gauges positioned near the ocean, which actually measure the height of the ocean. The other one is satellites. Satellites now measure the height of the ocean, and there are some really smart people that take into account the shape of the ocean surface, because of course it's not flat, tides, heat content, and a whole range of things. I'm not the expert in the measurement of sea level rise. But people like John Church, if you want to Google him, are world experts in the science of sea level rise, and you'll be able to learn more about it. But it's now mainly measured by satellite.
Wes Taylor, I think you've answered this question, Professor Pitman, but Wes has asked, how soon will we reach the extra 2 degrees on today's 40 billion tonne emissions per annum?
So the answer to that question is, to what degree of certainty? So if you want a toss of a coin chance, 2 degrees, we've got 32 years at current emission rates. At an 83% chance, we've got 21 years. So these questions can't be answered with a single number. It has to be answered with a likelihood. So given that you wouldn't get on an aeroplane with a 17% chance of crashing, I don't like a 17% chance of failure to make the targets. But if I'm willing to accept a 17% chance of failure, 21 years.
There's always, as statisticians always make the point that it's irrational to be driving to the airport worrying about crashing in a plane. But anyway, it's a separate issue. Daisy Rebecca, I think. Yes, all right. So Daisy Moore, one of my favourite names, Daisy. Can Professor Pitman please elaborate on the carbon budget and what that means to exhaust it? Thank you.
I can. So there is a very simple relationship, what's called a linear relationship, for those of you who know what that means, between how much the planet will warm and how much carbon has been emitted through human activity since the Industrial Revolution. When you emit CO2 into the atmosphere, it stays up there for about a century or so. So you can measure the total amount of CO2 that's been emitted through human activity and relate that to temperature. And that relationship seems to hold really strongly. What that means is for a warming of 2 degrees, you can easily read off that graph how much carbon can be emitted to limit warming to 2 degrees. You know how much carbon's been emitted to date, and that gap is the remaining carbon budget. I hope that made some sense. And one can also work out how long it would take to exhaust that carbon budget. It's important to understand the carbon budget is forever. So it's not renewed every year. It's not like the federal budget that you can pay back or whatever. It's a total amount of carbon that you can emit to avoid a certain amount of warming in human lifetimes. And we are rapidly spending it.
So in the interest of openness and transparency, Rebecca, who is guest, says it's time for politicians like Jason to become part of the solution and not continue to exacerbate the problem. Would you like to comment, Professor Pitt?
I think all politicians should inform their decisions using science.
You said you have a career in diplomacy after after we've solved this global warming. Michael Mathert asks, how do you measure temperature that relates to the climate as opposed to the weather?
So most simply, the climate is a 30-year average of the weather. So the idea with climate is by averaging over 30 years, you average out the variability that's regularly there as a consequence of El Nino, La Nina cycles, or a range of natural oscillations. You measure that using usually a thermometer in a Stevenson screen or its equivalent. Those are taken all the way around the world according to standards imposed by the World Meteorological Organization, but increasingly we supplement that now with satellite observations of temperature. In the ocean, you measure using a whole range of things ranging from buoys through direct measurement from ships, but you can also measure the ocean heat content, which is related to temperature. So yeah, basically thermometers, and when you use a thermometer for a day, it's measuring weather. When you integrate those measurements over 30 years, you get a climate measurement.
Thank you. Hillary wants me to thank you, Professor Pitman, with an exclamation mark.
Excellent.
Rodwell says, GE, I think, how will you make your steel? Green hydrogen is probably 10 to 20 years away, commercially, according to BlueScope.
No idea. Sorry, I'm not an engineer.
Guest has a reasonable screed here about why nuclear is important for us to get going with. Michael Mathert asked, can you give 2 examples of extreme events? When people talk about extreme events, what should we think of?
Heat waves, extreme windstorms. Okay. I suspect he might mean what extreme events are changing. The biggest is heat waves. The evidence around the frequency, magnitude, and duration of heat waves is extraordinary. But we also, for instance, can measure now clear evidence of intensification of rainfall events.
Then we've got Margaret Stanley asks, What about China and India? Surely they have to change too.
Yep. I mean, remember that the problem we have now is almost entirely not the fault of China and India. The reason we have a problem now is to do with Western economies and the Industrial Revolution. Moving forward, they become a really big part of the problem if they develop using the technologies that Australia and Europe and the US used. So at the moment, it's fair to say they shouldn't be held accountable. But moving forward, if they aren't supported in not burning fossil fuels, they'll dwarf the contribution made by the Western economies over time.
Okay. We've only got a few minutes left, so I'm trying to think of the. Is Professor Pitman aware of the new nuclear technology funded and promoted by Bill Gates? It apparently uses nuclear waste as feedstock and cannot melt down. So this is the wave reactor. I don't know, Professor Pitman, if you want to add to it. This is the wave reactor. It's the name of the company is called Fermaterra, I think. And basically, in Biden's recent $1.2 trillion green fund, $400 billion went to the construction of 4 next-gen nuclear reactors, of which included the wave reactor. It doesn't use waste. Current technology of nuclear reactors, they only actually use about 5 to 10% of the uranium. The rest then gets stored in what's called depleted uranium. Most of the new SMEs, which are modular reactors, use up to 70% of the rod, which means they can use what is currently nuclear waste to basically run it down to very close to 10%, which means its half-life is more than halved. Can you talk about the, yes, Anna asks, can you talk about the impact of climate change on Australian food production?
That depends critically where you are. Where rainfall or irrigation can continue to support Australian agriculture, the higher carbon dioxide in the atmosphere can help encourage Australian agriculture, and there has been phenomenal levels of innovation in Australian agriculture over the last few decades that has withstood a lot of the climate changes we've observed. Where the rain declines, then agriculture has an immense problem. So it depends which kind of agriculture you're talking about and where you're growing the animals or the crops. It's hard to answer that in a general way. There are areas that will be benefited and areas that will be disadvantaged, which is why Brown Brothers sold up on the mainland and moved my favourite grape to Tasmania.
I should also mention there's a great book called The Future of Food. And one of the other reasons that Australia should sign up to net zero, COP26, is that the number of technologies coming down the line around food production, particularly cell-based meats. There's a think tank in North America that says the size of herds will be halved by the end of this decade. And that means that farmers and regional communities will be looking for other forms of income. And there's very little doubt that soil sequestration would be a regular form of income for a lot of farmers if we can get that to work.
Yep.
Anna would like you to come back and so that you can talk for longer because this is a very important issue. So that's an invitation. Rebecca says we owe it to our children to put aside the climate wars. Yes, Rebecca. Rod asked, Professor, is your modelling superior to our COVID modelling? I'll take that as comment, Rod.
Well, if I may just comment.
Yes, of course.
We have an advantage in modelling the Earth's climate that most other modelling groups don't have. So whether it be economic modeling, the famous modeling that talked about there only being the need for 3 computers in the world, there's many examples you can go through that show modeling can be extremely unreliable. The advantage we have in climate science are the laws of physics. All we're doing in our climate modeling is effectively tracking energy through the climate system, not using regressions, but using the basic laws of physics. And we can show, based upon performance of those models in the past, that they work really well because the laws of physics are right. So it's not reasonable to say the question, I understand the question, but don't compare all kinds of models or don't think of all kinds of models as meaning the same thing. I am disparaging of economic modeling, but there's no laws underpinning economic modeling. Those laws of physics are right, and sadly they weren't invented by climate scientists, but we don't invent these things ourselves. So yeah, our models are better than those used in COVID because there's no laws underpinning how COVID spreads around. It comes down to human actions, not basic laws of physics.
And I fear, I'm afraid, Professor Pitman, that I will have to ask you to come back because there are lots more questions and perhaps we can get the technology right. Hint, hint, Nick, and so that you can do this with PowerPoints. But there is one last question, which I think is actually a really good question. And it's from James Nichol. And he asks, how do climate scientists maintain hope given the current world politics?
I admit I was kind of giving up. But I've been working a little bit in the last 18 months in the nexus between climate science and the financial sector. And I am seeing how fast global capital is moving from fossil fuels to renewables and other technologies. It is amazing how fast trillions of dollars are shifting where they go to as a consequence of investors wanting to take this issue seriously. So people who don't believe in climate change, that's fine. But if you are investing in things that are past technologies, you're going to get burned. The massive change in the flow of capital is eye-watering, and it's why Australia will actually have no choice but to sign up to net zero emissions, because if it doesn't, it will cease to be able to attract investment from overseas.
And I shouldn't do this, but if you will allow me, I do also think the other key reason for it is that we massively need to be at the forefront of those discussions on a whole range of different things that if we haven't signed up, we can't be a part of. So everything from how you actually calculate carbon, how you register it, even before you get to trading systems and things like that. And as we talked about earlier, farmers in Australia will rely more and more heavily on sequestration for income, and if we're not at the table at the beginning, how that's calculated, how that's set out, and how it's traded and sold, we could potentially be shortchanging ourselves. Professor Pitman, can I just say this has been fascinating. If you are up to it, if you want to run the gambit once again of our technology, we would love to have you back for another time, maybe on the other side of Christmas when we're all out in freedom. But we very much enjoy having you along today and your no-nonsense response to questions.
It's always great to have to answer questions on a tight timeline. I could have spoke for an hour on half of those questions, and your team and your electorate would have got very bored. But yeah, happy to come back and answer any other questions.
Thank you very much. And thank you for everyone who joined us today. Some people asked, would this be available. Yes, it's been recorded. We'll just have to trim it down because of the first beginning bit, and then we'll post it to my YouTube channel. Thank you, everyone. Thank you, Professor Pitman. Have a great day. Bye-bye.
Bye-bye.